Good evening, children. Hello. Good evening to all.
Good evening, ma'am.
Okay, everyone, please turn on the videos. Right. So yesterday we completed with integers, right? We did the revision of integers and I had shared some worksheets with you. Did you try those worksheets? Yes? Were you able to do?
Ma'am.
Okay. Any difficulty? Anyone? You can ask. Okay. If you have not completed, you can complete it. Okay. Take your time, but complete it. That's for your practice. Okay, so today we'll be doing the chapter Understanding Elementary Shapes. Okay, this is another important chapter which is going to be very helpful to you in your senior class when you do geometry. Right? Okay, so let's move to understanding elementary shapes. Okay, elementary shapes are the basic shapes like geometry, triangle, rectangle, square. How do we means their properties? All those things you will be studying here. So initially starting with the point, ray, line segment that is already studied in basic geometrical ideas. Okay. So starting with that. Now, first thing here is that when you are reading a scale, okay, how do you read a scale with accuracy? Does anyone remember when we had done this chapter earlier? If you want to read the scale with accuracy on the ruler, if you want to read with accuracy, how do you read it?
You have to use divider.
Yes, you use divider for that. Okay. Now, what is the purpose of using a divider? Suppose if you are measuring some line segment and I say you use a divider, why not with a ruler? Who can tell me? Nishika? Hello?
Yes, ma'am.
Yes, Nishika, can you tell me why don't we do with ruler? Why do we prefer divider? Okay. Yes, Shriyansh, can you tell me?
Yes, ma'am. Ma'am, it is better to use a divider than a ruler, ma'am, because ma'am, sometimes ma'am rulers are like if our pencil is not sharpened, will not get accuracy, ma'am, and most of the times ma'am in the scales ma'am after using it after some time ma'am it will become curved and will can give us incorrect readings ma'am. So we have to use divider because it has a sharp point which will be accurate.
Yes, that's correct. And one more thing I would like to add on to it, that the thickness of the ruler also gives us inaccuracy.
Yes ma'am.
Okay, many times you have seen the rulers are thick. Yes, you have seen with wooden rulers, they're so thick. So they don't give us the accurate measurement, right? So the best thing is that to keep a divider at those points and then measure it, right? Okay, so here you have the first question in this. What is the disadvantage of comparing line segment by mere observation? What is the by observation? Observation means just by seeing. So when you just see something, I tell you, okay, this is a line, and just by seeing, what estimate can you make out? Whether it is something 3 centimeter, 5 centimeters. So this is just an estimate. Okay. 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 Now let's read the next question. Okay. Why is it better to use a divider than a ruler while measuring the length of a line segment? Yes, so just now we discussed about it. Why do we use a divider? Now, Nishika, is it clear now? Hello? Hello, Nishika, can you hear me? Shriyansh, can you hear me?
Now I can hear you.
Okay, let's see the next question. Draw any line segment. Say the line segment is AB. Take any point C lying in between A and B. Okay. So that means we have taken a line segment from A to B, right? This is point A, this is point B. And in between it is saying there is a point C on it. Measure the lengths of AB, BC and AC. So AB is this, BC is this and AC is this much. Is AB equals to AC plus CB? Yes. How can we see that? If AB and C are 3 points on the line such that AC plus CB is equal to AB, then we can be sure that C lies in between A and B.
Yes, ma'am.
Okay, so that's but obvious. So we just make a line of any centimeters, okay, and randomly take any point C in between them, right? So we can just take any line segment. Suppose I take some line segment 8 centimeters and at 5 in between I make this point. Okay, so I can just measure AC distance and CB distance. And when I add them, that distance will be equal to the AB. Please pay attention. Okay, let's see. If A, B, C are 3 points on the line, such that AB is 5 centimeter, BC is 3 centimeters, and AC is 8 centimeter. Which one of them lies between the other two? Okay, Shriyansh, let's do this. Now it's saying AB is 5 centimeters, from A to B is 5 centimeters, and B to C is 3 centimeters. And AC is from A to C, it is 8 centimeters. Okay, which one of them lies between the other two? Which point is lying between other two?
B, ma'am.
B, right? So this much distance is 8. This is 5. 5 plus 3 is 8. So B lies between the two. Okay, next is verify whether D is the midpoint of AG. Now you have this line segment. You have your A over here, right? G over here. Now you have to verify that is D the midpoint of line segment AG? Yes, just check out. Yes, Nishika?
Yes, ma'am.
Is it? Is D the
Ma'am,
midpoint?
D is the midpoint of AG.
D is the midpoint. Okay, if you are saying D is the midpoint, then what is the distance between AD? What is AD distance? Yes, see, how much is AD distance?
Ma'am, 8 centimeters.
How many?
8 centimeters, ma'am.
8. This is what you're saying.
Ma'am, because AB is 5 centimeters, right? And then BC is...
No, 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 my dear, we are doing this question. Question number 5. We are doing question number 5. Okay. Although it is not asked in the question, in the question it is just asked to verify whether D is the midpoint or not. So you are saying D is the midpoint. So my question is, how did you find that D is the midpoint? How much is
Ma'am,
distance AD?
Ma'am, since A, B, and C, and D is in the middle, and then E, F, G is in the middle.
So how much is the distance A to B?
Mom, 5 centimeters.
See, it's here. A to B is 1 centimeter, 1 centimeter, then 2 centimeters,
Yes.
then 3 centimeters. So it's 3 centimeters I can write.
Yes, ma'am.
This is also 1 centimeter from D to G. 1 centimeter, 2 centimeters, 3 centimeters. Yes.
Okay,
So
ma'am.
that means on either side of D, I have equal distances, no? So that's why I can say that D is the midpoint. Yes.
Yes, ma'am.
Okay, let's see the next. If B is the midpoint of line segment AC and C is the midpoint of BD, where A, B, C, D lie on a straight line, say why AB is equal to CD. Okay, now just see here. Just make a figure in your notebook. If B is the midpoint of AC line segment, make it in your notebook. Now this is some line segment AC and it is saying that B is the midpoint. Okay. Of B and C is the midpoint of BD. Now C is the midpoint of BD. B is the midpoint of A to C and C is the midpoint of BD. That means if we stretch this further more, we get this point D here. And it's saying C is the midpoint of BD, where ABCD lie on a straight line. Say why AB is equal to CD. So how can you say that this part AB is equal to CD? Yes, how can we say that?
It's the measurement of the like if it's even number one, the measurement of the line.
See, it is given that B is the midpoint. That means AB and BC distance are equal. AB is equal to BC. We can say that.
Yes, ma'am.
Yes. Everyone please listen. AB is equal to BC because we are given B is the midpoint. And further we are given that C is the midpoint of BD. This is again the midpoint of BD. That means BC is equal to CD. BC is equal to CD also because C is the midpoint. Yes.
Yes, ma'am.
So when AB is equal to BC and this BC is equal to CD, so we can say that AB is equal to CD. Yes. Yes. Understood this much?
Yes, ma'am.
Everyone? Nishika, Adya? Hello? Nishika, Adya? No
Yes.
answer? Okay. Adya? Okay. Now see this question number 7. Draw 5 triangles and measure their sides. Check in each case if the sum of the lengths of any two sides is always less than the third side. Oh, that the sum of, it's saying the sum of the two sides, sum of the lengths of two sides is always less. Is it? So you have to check by making 5 triangles. So just make 5 triangles in your notebook of any length. Make 5 triangles and check out that the sum of two sides is less than the third side or greater than the third side. Make any triangle in your notebook. Everyone please do. Make just 2-3 triangles. Okay.
Yes, ma'am.
Yes. So what did you find?
It's not correct.
What did you find?
Those are bigger than the third side.
So in every triangle you will find that the sum of the two sides is always greater than the third side. It's never less. Okay. All right. Check out Nishika and Abhya. Whatever triangle you make. Okay. Whether you are making some isosceles triangle or scalene or any triangle. The sum of two sides will always be greater than the third side. Okay, let's move further. Nishika and Adya are not responding. Yes, Riyansh, that's good.
Ma'am, my Wi-Fi isn't good today.
Okay. Okay. And Adya, what about you? Adya, can you hear me? Yes, Adya. Adya is not there. Hmm. Okay. Now next is the angles, right? And straight angles. Okay, let's now see what is the right angle. See everyone here. See, when we know about the directions, north, suppose this is north, south, and directly opposite to north is the south direction, right? And on the right side of the north is the east direction. When you move clockwise towards, when you move clockwise from north direction, you have the east direction, right? And exactly opposite to east is the west. Okay, so that means okay. Oh, what is this? One second, I'll share the screen again. Okay. So are you understanding? We have the four directions like this in opposite directions, right? Opposite to north is south, and when we from north direction, when we move clockwise, we have east direction here. And exactly opposite to east is the west. Now, if you see the angle between north and east, this angle is 90 degrees. Okay. And if you see the angle between east and south, this is again 90 degrees. This is again 90 degrees between south and west. Between west and north, this is again 90 degrees. So that means this part, we call it as 1/4, right? We call it as 1/4. And 1/4 is 90 degrees here, right? 90 degrees is, we call 90 degree as right angle. Okay, children? And then we have two 90-degree angles. Suppose I have this 90 degree and this side also if I have 90 degree. Okay. So I will call 90 plus 90 will become 180 degree. Okay. And this 180 degree is called straight angle. Right? This is called straight angle. 190-degree angle is like this, when the two sides are standing perpendicular to each other. And straight angle is like this, when the two sides are in the same line. Both the arms of the angle are in the same line, right? Then, suppose if your angle is still further greater than 180 degrees, so that means it's this side and here like this. So that means it will be 270 degrees. So 180 plus another 90 will be 270 degrees. Right? Okay. And the angle from 180 and 360 is all reflex angle. Okay, so when you add another 90 degree, another quarter to 270 degree, you get complete angle, that is 360 degree. This is complete angle. Okay, and all the angles, see, till 360 degree is complete angle. From here to here is 360 degrees. But the angle which is greater than 180 and less than 360, that means in this lower part, is called reflex angle, right? So angles greater than 180 and between 180 and 360 are called reflex angles, right? Are you understanding? Okay. Now see here. Now see, these are the hands of a clock. One needle is pointing at 12, another needle is pointing at 6. So what is the angle between these two needles of the clock? You can see they both are in a straight line, right? So that means from here to here, the needle moved from here to here like this. That means it made half a revolution. Yes, I said that when you have an angle, when your one arm of the clock takes complete revolution like this becomes 360 degrees. Yes,
Yes, ma'am.
started from 0 degree till complete revolution is 360. But now what happened? Your needle started from here and it stopped here. So that means it's in a straight line. So that means it's a half revolution. So it is making two right angles. Okay. All right. Further, you have 1/4 of a revolution. Now your needle is at 6 and it moves 90 degrees towards in a clockwise direction. Right? So that means 90-degree move means 1/4 of a revolution. Why we are saying 1/4? Because 360, when you multiply with 1 by 4, what do you get? Okay. Yes. So this means 90 degree is 1/4 of a revolution. This is just a quarter part of it. 3/4 is taking 390 degrees, making 3 right angles, right? 3/4 of a revolution means making 3 right angles. 1/4 of a revolution is making 1 right angle. Half revolution is making 2 right angles. I hope you are understanding.
Yes, ma'am.
And 4 right angles is complete revolution. Okay, so that's complete revolution. Okay, now here comes. So next exercise. What fraction of a clockwise revolution does the hour hand of a clock turn through? When it goes from 3 to 9. Now you will tell me, when the clock hands are moving from 3 to 9, how many revolutions is it covering? How many clockwise direction does the hour hand of the clock turn through? That means you will tell me in right angles. How many right angles it is turning through? From 3 to 9. See, your clock is like this. Yes. So from 3, this is 3. From 3 to 9. So it moved from here to here. Yes, it's saying in clockwise direction. It's written no? Clockwise means moving in the direction of a clock. Okay, when the needles, how the needles of the clock move? Like this. So moving in the direction of the clock is called clockwise direction, and moving in the direction opposite to the direction of a clock is anti-clockwise direction. So that means from here to here, it has moved through 2 right angles. Okay. Now tell me from 4 to 7. Nishika, can you tell me from 4 to 7, how many right angles will it move through? Yes, Nishika? Hello, can you hear me, Nishika? Hello? Are they Adya, can you hear me? Okay, Shreyansh, you tell me.
Ma'am, 4 to 7.
Yes, 4 to 7. How many right angles is it turning through?
Ma'am, 1.
Hmm?
1, ma'am.
1. How many right angles is 1? So that means how much is the fraction? What
1 by 4.
fraction? It's saying what fraction. So 1 right angle means 1/4. Okay, and this was how much, how many fractions? When it was 2 right angles means what fraction was it?
2 by 4.
Yes,
Ma'am, 2 by 4.
2 by 4. So 2 by 4 can be written as 1 by 2.
Yes, ma'am.
Okay, so we can write as half the revolution. Okay, then from 7 to 10, tell me now.
Ma'am, 1 by 4.
Okay, 7 to 10 is 1 by 4. Next, 12 to 9.
Ma'am, 3 by 4.
Very good. Next, 3 by 4. Nishika and Adya, if you can hear me, please respond. You can also give the answers. Okay, 1 to 10. Tell me.
Just a moment.
Yes, yes.
Ma'am, 3.
1 to 10 is
3, ma'am. 3 right angles.
3 right angles. So that means it's making 3 by 4 of the complete revolution.
Yes, ma'am.
Okay. Then 6 to 3. Now 6
ma'am.
is here, then moving
Ma'am,
clockwise.
one.
Yes.
1, ma'am.
6 to 3, beta. See, you're in the needle. 6 is here. It's making clockwise waves. It will start from here and it will end at 3. So how many right angles? This is one right angle here like this. Another right angle and another right angle. So this means how many? 3/4 of a revolution. Yes.
Yes, ma'am.
Okay, Nishika. Okay, next question. Where will the hand of a clock stop? Okay, you have to tell me where will the hand of the clock will stop. If it starts at 12 and makes half of a revolution in clockwise direction. Now just keep the clock in your mind like this. Okay, right? You can make it in your notebooks. Okay, this is the clock. Now it starts at 12 and makes half a revolution. Where will it stop? 12 is here. So it started and taking half a revolution. Where will it stop? Yes, at 6. It will stop at 6. Okay, next one is starts at 2 and makes half of a revolution in clockwise direction. Yes, from started from 2 and make half of a revolution. So where will it stop? Half a revolution is how much?
Ma'am, 8.
Yes, it
8,
will
ma'am.
stop at 8. Very good. Okay. No one else is answering. Nishika, Adya. Okay, next one is starts at 5 and makes 1/4 of a revolution in clockwise direction. Now 5 is here. Starting from 5 and making 1/4 of a revolution. Where will it stop?
8.
Yes,
8, ma'am.
8. Good. Now starts at 5 and makes 3/4 of a revolution clockwise. Now tell me, from 5, 3/4 of a revolution.
2, ma'am.
2. Good. Okay. I hope all are understanding. Nishika and Nadia, your mics are not working, so you can write in the chat box if you have any doubts. Okay, let's see. Question number 3. Which direction will you face if you start facing? Now, if you start facing east and make half of a revolution clockwise. Now you are standing towards east. Now just see the directions are here: north, south, east, west, like this. So it's saying that you are facing towards the east and you make half the revolution clockwise. So where will you stop?
Right.
West. Okay. So now you are standing towards east and make 1.5 revolution clockwise.
South, ma'am.
So 1.5 revolution. One revolution is complete circle, right? Started from east, ended at east. Then another half. Okay. So 1.5 is west. Okay. Next is west and makes 3/4 of a revolution in anti-clockwise direction. Now you are facing towards the west and you make anti-clockwise. Anti-clockwise is opposite to the direction of clock. 3/4 of a revolution. Where will you reach then?
Ma'am, north.
North. Okay. So anti-clockwise is this type of a direction, this way. Okay. So making 3/4 of a revolution, you will end at north. Now south and make one full revolution. You are facing towards the south and you make a full revolution. Where will you reach now? Yes?
Ma'am, it doesn't matter.
Absolutely, yes. Okay, so one full revolution means you will reach at the same point.
Yes, ma'am.
Okay? And it does not matter whether you are moving clockwise or you are moving anti-clockwise. Okay? Okay, good. Okay, next is what part of a revolution have you turned through if you stand facing? Okay, what part of a revolution you have turned through? That means now you have to tell how much fraction have you turned through. If you stand facing east and turn clockwise to face north. Yes? You are facing towards the east. Now this is the east direction and you turn clockwise to face north. You turn from east, you turn like this, like this, like this, clockwise to face north. So that means you have taken 3/4 part of a revolution.
Yes, ma'am.
Are you understanding? So you have taken 3/4 of the revolution. Now, okay, now tell me this one. You are facing the south and turn clockwise to face east.
3/4, ma'am, again.
Again 3/4. Okay. West and turn clockwise to face east.
2/4, ma'am. Half. 1/2.
1/2. Okay. Okay.
Yes, ma'am.
Next is find the number of right angles turned through by the hour hand of a clock when it goes from 3 to 6. So number of right angles you have to tell. Okay. Turn through by hour hand of the clock when it turns from 3 to 6. So clock is turning from 3 to 6. How many right angles has it moved through? Yes.
1, ma'am.
How many?
1.
1. Okay. Okay. Tell me for the next one.
2, ma'am.
From 2 to 8. 2 to 8 is 2 right angles. Okay. From 5 to 11,
Again 2, ma'am.
2 right angles. From 10 to 1,
1, ma'am.
1. Okay. From 12 to 9,
3, ma'am.
12 to 9 is 3. 12 to 6,
2.
2. Nishika, Adya, you can write your answers in the chat box. If your mic or you have some Wi-Fi problem, you can write your answers in the chat box. I hope everything is clear to everyone. Yes, is it clear?
Yes, ma'am.
Okay, let's see the next. How many right angles do you make if you start facing south and turn clockwise to west? If you start facing south and you turn clockwise, you make the north-south direction in your notebooks. Check out. Yes. Yes.
One.
Yes. So that's one right angle. Okay. North and turn anti-clockwise to east. You are standing towards the north and turn anti-clockwise to east. So how many right angles? This is your north, this is south, east and west. So from north anti-clockwise you are moving till you reach the east direction. So how many right angles? 3. Good, Nishita. West and turn to west. Yes. So how many right angles? Coming at the same position. Yes, say. One revolution, sorry, this is 4 right angles, no? One complete revolution, so 4 right angles. Now you are facing towards the south and you turn to north. From south to north. Yes. How many right angles? Say.
South to north, 2.
2. Where will the hour hand of the clock stop if it starts? Okay, then next question is, you have to say where will the hour hand of the clock will stop when you start from 6 and turns through one right angle. You start from 6 and turn through one right angle. So where will it stop?
9.
It will stop at 9. When you turn from 8 and turns through two right angles. Starting from 8 and taking two right angles.
Ma'am, 2.
2. Okay. So this is 2. Okay, from starting from 10 and turns to 3 right angles.
Ma'am, 7.
7. Okay. When you start from 7 and turns through 2 right and 2 straight angles. 2 straight angles is what is 2 straight angles? One straight angle is 180 degree, no?
Full revolution, ma'am.
Yes, so that's full revolution. So 2 straight angles is 180 plus 180.
7, ma'am, 7.
7 only. Okay?
Okay.
Okay. Now, angles acute, obtuse, and reflex. Okay, just now we discussed about reflex angle. Acute angle, you know, angles lying between 0 and 90 are called or acute angles. Okay, between 0 to 90 degree are all acute angles. Angles greater than 90 degrees, all angles greater than 90 degrees, okay, are obtuse angles. So that means greater than 90 means from 90 to 180 degrees, which lie between 90 and 180 are all obtuse angles. And reflex angles, I told you, all angles from 180 to 360 degrees. Okay, in between the angles which lie in between 180 to 360 are called reflex angles. Okay, and the complete right angle, the 90-degree angle is called right angle. The complete 180-degree angle is called straight angle. Okay. And the complete revolution is called 360 degrees. Okay.
Okay.
Okay. So here you have some match the following. Straight angle. Now just read the options first. Read both side options. Okay. 1 second, children. We'll continue this in the next class. The class time is done now. Okay. So we'll continue in the next class. Okay. We have still more exercises. There are some exercises in this.
Yes, ma'am.
Okay. So thank you so much for today.
Thank you, ma'am. Bye.
Okay. Please revise this and you have your Sunday test also live. Okay. Do that.
Have a nice day.
Bye bye.